Okay, so in this video we're going to look into quadratic residues, and what we're going to see is if our residues modulus are prime, follow some sort of sequence when they're put in numerical order. So the rules for this sequence are going to be governed by these two boxes. So the prime numbers got to follow either one of these. You can see 29 and 31 will follow one of each of those boxes. And then we're going to follow these four rules to find out what's going on here with these. Okay, so first of all, we're going to find out the quadratic residues modulus 29. So what we need is to solve this equation first. If x squared congruent with a mod 29 has a solution, then we can say that this number a is one of the quadratic residues. So we need to find a shortcut to find the quadratic residues of the numbers up to 29. Now if we go through from 1 to 29, it's going to take too long, so we need to find a shortcut. So first of all, we know that all the square numbers that give us a solution up to and including 29 will give us a quadratic residue. So as 29 is just larger than 25, we know that 1 to 5 square numbers will give us a solution. So I'm just going to write them all up here, the first 5 square numbers. So we know that these are quadratic residues because if x squared is congruent, for example, with 16, we know we can find a solution with this. Just take the square root of both sides and then we'll end up with a 4. So that's going to give us a solution. So we've got up to 5. So now we need to start from 6. And all we need to do is go to just past halfway with it's an odd number. So for 29, we just add 1, divide by 2, which will give us 30, and then divided by 2 gives us 15. So all we need to do is go from 6 to 15. So 7 squared, 8 squared, 9 squared. And what we do is now we just square these numbers and then find the lowest integer, positive integer, modulus 29. So 6 squared gives us 36, and then 36 will yield a 7. So we could just say that that is congruent with 7. Okay, so 7 squared gives us 49, modulus 29, that will give us 20. 8 squared is 64, 29 times 2 is 58, so that will give us a 6. So all these numbers here will be quadratic residues in this column here. So 81, 2 29s are 58, so the remainder here is 23. So that gives us another quadratic residue. 10 squared, well 10 squared is 100. Modulo 29, well 87 is 3 29s, so that gives us 13, modulo 29. 121, so modulo 29 of that, lowest positive integer. 4 29s are 116, so that's going to give us a 5. 144, so 29 times 4 is 116, so that's going to give us a remainder of 28. 169, so 5 29s are 145, so that's going to give us a 24. 14 squared, 196. So what can we use here? 5 29s are 145, so we need to go one more. 6 29s, 174. So that's going to give us 22 left over. Okay. 15 15s, 225. 225, or 7 29s are 207. So that gives us 18 left over. Okay, so I've written all the quadratic residues in numerical order. So now we need to find which one of these boxes is working for this condition here for prime number 29. So 29 is prime, and we can see straight away 29 is congruent with 1 mod 4. So nothing special in that. So here the first box is what's important to us. So I'm just going to write this up first and then I'm going to explain to you what that means. So for P we write 29, so we've got 29 minus 5 over 4. Well, 29 minus 5 is 24, over 4 equals 6. So what we see here is A00 is quadratic residue is followed by a quadratic residue. And what this is saying is there is 6 instances where a quadratic residue is followed immediately by a quadratic residue. So let's see if that comes good. So 1 is our first, well the next one is 2, which is a non-quadratic residue. And then we've got 3 after that, which is another non-quadratic residue or quadratic non-residue. Either way is good. And then we come across the number 4. So that is a quadratic residue. And we can see straight away that 5 is a quadratic residue. So straight away we've got 1 instance of a quadratic residue following a quadratic residue. And then 5 follows 6, and that gives us another one. 6 follows 7, and that's another one. Now 7 follows 8. 8 is a quadratic non-residue, so that's no good to us. 8 follows 9, so that's not part of this sequence. Then we've got 9 follows 10. 10 is a quadratic non-residue. 11 is a quadratic non-residue. 12 is a quadratic non-residue, that's not important to us. And then we come across to 13, that's a quadratic residue. But then we see 14 and 15 are quadratic non-residues. So then we've got 16. Following 16 we've got 17, 18, 19. They're quadratic non-residues. And then we come to 20. 20 is followed by obviously 21, which is a quadratic non-residue. And then next we're in business here, we've got 22 followed by 23. So that's a sequence of quadratic residue followed by quadratic residue. 23 follows 24. That's another one. And then 24 follows 25. That's another one. So we're up to our 6 here, so now there shouldn't be any more, as which we can see 26, 27, 28 quadratic non-residues. Well, 28 is the quadratic residue, but no instances of following. So I'm going to write here 26 and 27. So that's our last 2 quadratic non-residues. So A00, quadratic residue followed by quadratic residue. Now let's try A01. So A01 has got the formula P minus 1 over 4. So we've got 29 minus 1 over 4. So that's going to give us 28 over 4, which is 7. Now A01, as you can see, is quadratic residue followed by a quadratic non-residue. So we need to find the sequences when this happens. So 1 is then followed by a quadratic non-residue. So there's 1. So then we need to find a quadratic residue, which is then followed by a quadratic non-residue. So our next instance is 7. 9 is followed by 10, which is a quadratic residue, quadratic non-residue. 13 is followed by 14, so that gives us another instance. 16 gives us another instance. 20 is followed by 21, another instance. And then we go all the way along, and then 25 follows 26. So there we go, we've got 7 instances. So that's good, that's good. A10. So same formula, we're looking for 7, P minus 1 over 4. So A10, that's this same formula here, which we know gives us 7. So what we're looking for is quadratic non-residue followed by a quadratic residue. So follow this list of quadratic non-residues and then see if there's a gap which gives us a quadratic residue straight after. So 2, 3, so we then 3 is a non-residue which leads to 4, so that's 1. And then we got our next one is 8, which leads to 9, so that's another one. Then we've got 10, 11, 12. Well, 12 leads to 13, so that's another instance. Then we've got 14, 15. 15 leads to 16, so that's another instance. 17, 18, 19. 19 leads to 20. then 20 leads to 21, then we want 21 leads to 22, 26, 27, 27 leads to 28. So here we can see we've got 7 quadratic non-residues to a quadratic residue. And then just finally, let's see, we should get 7 of these. So that should be quadratic non-residue followed by quadratic non-residue. So we're only interested in this sequence here. So we've got 2 and 3, they follow each other. 8, 9, 10 follows 11, 11 and then 12, 14 and 15, 17 and 18, 18 and 19, 21, 26 and then 27. And you can see there's 7 in there. So we've shown that these sequences all work here for this particular one. You can try some other ones, you can try 33, you can try 37. Hopefully these will work. I'm going to leave that for you to try. So now I'm going to rub these off the board and then we're going to go to n equals 31. Okay, so now we're going to try for mod 31. So using the same system as we tried for the 29, we're looking for x squared is congruent with a mod 31. So we know all the solutions from 1 to 5 have all are all yielding quadratic residues. So we've got 1, 4, 9, 16 and 25 straight away. Now we need to go from 6 to 16. So 16 is just past half of 31. So 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So now we're going to square all these numbers modulo 31. Okay, so 6 squared is 36. 36 mod 31, that gives us 5. 7 sevens are 49. 49 mod 31 gives us 18. 64 mod 31, 2 31s are 62, so that's going to yield a 2. 9 squared yields 81. 2 31s are 62, so that's going to give us a 19. 10 squared is 100. 3 31s are 93, so that's going to yield a 7. 121. 3 31s, still using that, 90 is 93, so that's going to yield a 28. 144 for 12 squared. 4 31s, 124, so that's going to yield 20. 169. 5 31s, 155, so it's going to yield 14. 196. 6 31s are 186, so it's going to yield a 10. 15 15s, 225. Okay, so 7 31s, 217, so that's going to yield an 8. And then 16 16s, 256. So 5, 6, 7, 8. 8 31s are 248. So that's going to yield an 8. Okay, just check this 15, 225. 7 31s, 217. So that's also going to yield an 8. Okay, so therefore these are all our quadratic residues mod 29. I didn't put this other 8 in because it's already there. Okay, so I've written the quadratic residues and the quadratic non-residues for x squared is congruent with a mod 31. So now let's check this table here. So 31 is congruent with 3 mod 4 and 31 is a prime. So let's calculate A01 first. So A01 is quadratic residue to quadratic non-residue. And our formula is p plus 1 over 4. So our prime number is 31. So 31 plus 1 over 4, that's 32 over 4, that gives us 8. So there should be 8 in the sequence which gives us quadratic residue followed by a quadratic non-residue. Okay, so if there's gaps in this table, that's the ones we want to count. So 2 leads to 3, so that's 1, 4, 5, 5 then leads to 6, then we've got 7, 8, 9, 10, 10 leads to 11, sorry I just put a 1 there, not a 6, 10 leads to 11, then we've got 14, got a gap after it, 16's got a gap after it, 17, 18, 19, 20, 20's got a gap after it, 25 has got a gap after it, and 28 has got a gap after it. So there should be 8 here. So 1, 2, 3, 4, 5, 6, 7, 8. So that holds good. Now for these, we need p minus 3 over 4. So p minus 3 over 4, 31 minus 3 is 28, over 4, that's going to give us 7. Okay, so incidentally, you should see that these three totaled up. 3 7s are 21, plus 8 is 29. So 29 numbers in the sequence should work for this. Okay, 0, 0 is quadratic residue followed by quadratic residue. So let's see where they are following each other. So 1 is followed by 2. Then there's a gap. 4 follows 5. Then there's a gap. 7 follows 8. 8 follows 9. 9 follows 10. Then we've got a gap. 14 gap. 16 gap. 18 follows 19. 19 follows 20. And then that's it. So here there should be 7, of which there is. So that's good. Now A10. So that should be 7. A10 is a quadratic non-residue followed by a quadratic residue. So let's go through this table. So non-residue first, and then there's a gap. 6, and then there's a gap. 11, 12, 13, then there's a gap. 15 leads to a gap. 17 leads to a gap. 21, 22, 23, 24, then there's a gap. 26, 27, then there's a gap. And then that concedes it. 29, 30. So we got 7 in the sequence. So this one's good. And then our last one is quadratic residue, non-residue to quadratic non-residue. So there should be 7 in this sequence. So if they're following each other in this line here, then we mark down. So 3, 6, 11, which follows 12. 12 goes to 13. 13 to 14 is a gap. 15 gap, 17 gap, 21 goes to 22. 22 goes to 23. 23 goes to 24. And then there's a gap. 26 goes to 27. And then 29 goes to 30. And that also gives us 7. So there we go. So I've shown a sequence here for quadratic residues, modulo a prime number. You can follow these. I'm going to leave you to try and find some other sequences here that you can give it a go.